Welcome to SS2 Further Mathematics, Term 3, Week 2. The Argand diagram is a geometric representation of complex numbers. It transforms abstract algebraic objects into visual points and vectors in a plane. This geometric view makes many properties of complex numbers intuitive and is essential for understanding loci, sets of points satisfying conditions, in the complex plane. By the end of this lesson, you will plot complex numbers on the Argand diagram, interpret modulus and argument geometrically, perform geometric transformations using complex arithmetic, describe loci of complex numbers, and answer WAEC further mathematics questions. Let us begin. The Argand diagram, also called the complex plane or Gaussian plane, is a coordinate plane where the horizontal axis represents the real part, y-axis or x-axis, the vertical axis represents the imaginary part, im-axis or y-axis. Each complex number z equals a plus by is plotted as the point a, b. Examples: 3 plus 4 I point, 3, 4, minus 2 plus I point, minus 2, 1, 2, 3 I point, 2, minus 3, minus 1, 2 I point, minus 1, minus 2, 5 point, 5, 0, on real axis, 3 I point, 0, 3, on imaginary axis. The complex number z can also be represented as a vector, an arrow from the origin O to the point a, b. Geometric meaning of modulus: z equals square root a superscript 2 plus b superscript 2 equals distance from the origin to the point a, b equals length of the vector oz. Geometric meaning of conjugate: z asterisk equals a, by is the reflection of z equals a plus by in the real axis. Geometric meaning of negation: z is the reflection of z through the origin. Addition of complex numbers: a plus by plus c plus d equals a plus c plus b plus d. Geometrically this is vector addition. The parallelogram law places vectors for z1 and z2 tail to tail. The diagonal is z1 plus z2. This is the same as adding displacement vectors in 2D. Multiplication by a real constant k. Kz stretches the vector oz by factor k, enlargement. Multiplication by I is as modulus is equals I z equals z, same length, and argument arg is equals arg I plus arg z equals 90 degrees plus arg z. Multiplication by I rotates the vector oz by 90 degrees anticlockwise. Geometrically, multiply by I equals rotate 90 degrees anticlockwise. Multiply by I superscript 2 equals minus 1 equals rotate 180 degrees. Multiply by I superscript 3 equals I equals rotate 270 degrees anticlockwise equals 90 degrees clockwise. Multiply by I equals 1 equals rotate 360 degrees equals back to start. In general, multiplying z equals r1 cis theta 1 by w equals r2 cis theta 2, zw equals r1 r2 cis theta 1 plus theta 2. The moduli multiply, the arguments add. Dividing z slash w, moduli divide, arguments subtract. This is the key rule for working with complex numbers in polar form. Geometrically, multiplication by a complex number w equals r cis theta rotates the vector by angle theta, scales, stretches slash shrinks the length by r. This has profound applications in 2D geometry and transformations. Distance between two complex numbers, z1, z2 equals distance between points z1 and z2 in the Argand diagram. This is used extensively in loci problems. A locus is a set of points satisfying a given condition. In the Argand diagram, conditions on z give loci. Locus 1, z, a equals r, where is a fixed complex number, r is a real constant. Geometrically, the set of points z that are distance r from point a circle with center a and radius are examples: z equals 3 circle, center origin, radius 3. z, 2 equals 1 circle, center, 2, 0, radius 1. z, 1 plus 2i equals 4 circle, center, 1, 2, radius 4. Locus 2, z, a equals z, b, distance from a equals distance from b. Geometrically, the set of all points equidistant from A and B perpendicular bisector of the segment AB, where A and B are the points A and B. Locus 3, arg z A equals theta, fixed angle. Geometrically, a ray, a half line, starting from point A at angle theta to the positive real direction. Locus 4, z A less than or equal to R, the set of points inside and on a circle disk. Locus 5, z A /z B equals K, a constant ratio. Using the formula for Cartesian form, this often gives a circle, Apollonian circle. Worked example, find the locus of Z such that Z3 equals Z plus 1. Z3 equals Z minus 1, equidistant from 3, 0, and minus 1, 0. Perpendicular bisector of the segment from 3, 0 to minus 1, 0 midpoint equals 1, 0. Bisector is the vertical line x equals 1. Algebraically, let C equals x plus I. x3 plus I equals x plus 1 plus I square root x3 superscript 2 plus y superscript 2 equals square root x plus 1 superscript 2 plus y superscript 2 x3 superscript 2 equals x plus 1 superscript 2 x superscript 2 6x plus 9 equals x superscript 2 plus 2x plus 1 dash 8x equals minus 8x equals 1. So the locus is the line re z equals 1. Complex numbers can represent geometric transformations of the plane, translation by vector, p, qw equals z plus, p plus chi. Enlargement with center origin and scale factor k, w equals kz. Rotation about origin by angle theta anticlockwise, w equals z times cis theta equals z times, cosine theta plus I sin theta. Reflection in real axis, w equals z asterisk, conjugate. Combining, rotation and enlargement equals multiplication by a complex number recurrent, I theta. WAEC Further Mathematics loci questions follow standard patterns. Find and sketch the locus of Z such that Z, A plus by, equals R. Identify a circle, find and sketch Z. Z1 equals Z, Z2, identify as perpendicular bisector. Express locus in Cartesian form by substituting Z equals X plus I, squaring and simplifying. Shade regions, Z, A, R means inside circle, Z, A, R means outside circle. Worked example, sketch and describe the locus Z, 2I equals 3. Center of circle is 2I, point, 0, 2, in Argand diagram. Radius equals 3. This is a circle with center, 0, 2, and radius 3. In Cartesian form, x plus I, y, 2, equals 3 square root x superscript 2 plus y 2 superscript 2 equals 3x superscript 2 plus y 2 superscript 2 equals 9. Shade, Z, 2I less than or equal to 3 is the closed disk, interior including boundary. Key points, Argand diagram, complex plane with real axis, horizontal, and imaginary axis, vertical, Z equals A plus by point, A, B. Modulus C equals distance from origin. Argument arg, Z equals angle with positive real axis. Complex conjugate equals reflection in real axis. Multiplication by I equals rotation of 90 degrees anticlockwise. General multiplication, moduli multiply, arguments add. Loci, Z, A equals a circle, center A, radius R, Z, Z1 equals Z, Z2 perpendicular bisector, arg Z, A equals theta ray from at angle theta. To find Cartesian equation, substitute Z equals X plus I and simplify. Transformations, translation, add, rotation, multiply by cis theta, enlargement, multiply by real K, reflection in real axis, take conjugate. WAEC test, plotting complex numbers, describing loci, finding Cartesian equations from complex locus conditions, identifying regions, inside/outside circles.